Now the third property we have is the reaction with halogen. So we have seen in this group that element react with halogen like fluorine, chlorine, bromine or iodine, forming the respective halides. For example, we have the element reacting with the halogen, forming the halides, and here the formula for the halides are basically, you can say E2X2, can be EX6, can be EX4, can be EX2, right. So this is the hexahalide, this is the tetrahalide, this is the dihalide. So for example, we see like and if we talk about the stability of the halides, we know that fluorine is more stable, chlorine is less than that, bromine is less and iodine is least. So we see that first we will talk about hexahalides. Hexahalides means of the formula EX6. So let us take an example of fluorides of this group. So it is SF6, it is SeF6, tellurium fluoride, hexafluoride. So if we see the structure of SF6, oxygen does not form hexahalide, first of all you should know. And then if you see the structure of SF6, we know that we have already done in bonding that SFC is something like this. That means it is sp3d2 hybridized. And if we talk about the stability, like rest of them are gases but they are unstable, but out of them only SF6 is a gas which is stable. And the reason is the steric factor, that is the steric group. The next we have is tetrahalides. We know that tetrahalides is 4. So let us see fluoride of this group. We see that is SF4, SeF4, tellurium tetrafluoride, like this. So if we talk about the states, this is gaseous and colorless, this is liquid and this is solid. That means down the group force of attraction is increasing. You should have to keep this in mind that in this group, when we are moving down, most of the time the force of attraction is increasing, whether it was oxide, whether it was hydride, the force of attraction was somehow increasing, not in the hydride, in the oxide and the halides. If you see the structure for SF4 or any of them, it is trigonal bipyramidal, one lone pair, like this, trigonal bipyramidal, F. So we will write F like this. And if actually if we talk about SF4 particularly, it can hydrolyze very fast. So what happened when we hydrolyze it, it quickly forms SO2 and HF. That means the hydrolysis is easy in this case. And there is a special property for SF4, and that is that it is a fluorinating agent. We have already discussed this, that fluorinating agent is something which can donate its fluorine. So it is the SF which here act as a fluorinating agent. The other type of oxide is E2X2. Let us take an example of sulfur. Let us this S2F2, S2Cl2, S2Br2, likewise we can have many. So here we are talking about only sulfur. You can do in for a case of selenium or tellurium, anything, means any member from the family. So we see that these kind of halides actually undergo disproportionate reaction. Breaks up into a smaller halide of respective formula SX2, which is sp3 hybridized. That means structure is something like this, that is the tetrahedral. And it liberates the element, like if we do it for S2X2, it will be SX2 plus S. So we see that a lot of different kinds of halides actually this group possess. So you should know about the structure, you should know about the hybridization, you should know about that. It means the first thing is that what type of halides they actually can form, right. So these are the important things, so just practice it at home, right.